Ruby is certainly my favorite dynamic language, but are the systems that we build with Ruby always the most dynamic systems? The story starts in 2012. I was moving from a place called Patients Like Me, which was a Ruby on Rails shop. I was moving to HubSpot. For me, that was a pretty exciting thing. HubSpot was obviously a company that was going places, but it was also a shift from Ruby on Rails back to Java. I had been there before. It had been slow. It had been challenging. Rails had been such a breath of fresh air. I was a little scared. I was worried that we were going back in time, that it was going to be slower and harder to get things done. But it turned out it was not so bad. Java had improved a lot over the years, and in particular, the way that HubSpot was using Java was building these systems that had lots of elements of dynamism and speed that I felt like I had gotten in Ruby on Rails, but now I had them in Java. So the first thing that really hit me over the head with this was feature flags. Obviously, not something that is limited to the Java ecosystem whatsoever, but for whatever reason, it was not something I'd been exposed to in Ruby and Rails, and they were just amazing. Because the way we had been doing things was, this was 2012, we wrote our Cucumber test, we built good code, we waited for a QA environment to be free, we would ship our branch to QA, I would ask the QA person to test my branch. Eventually, we would all merge things to main. On Friday morning, we'd ship these things to staging. All day, the whole team and QA would test on staging. We'd ship it to production around 1 or 2 on Friday, and then we'd roll it back because we inevitably broke something. Going to HubSpot, there's a much larger system, much more complicated. I committed to main, I pushed it to staging, I reloaded it and proved that it worked. I pushed it straight to production. And then I would find that I had indeed broken things. I didn't get to be much of a better programmer, but I'd only broken it for my single user because feature flags are amazing. I would go back to 1, I would ship to production 4 or 5 times a day, and this was amazing. Now, it was just life-changing for me. Feature flags was a revelation. That was only really the beginning of the dynamic systems because, the way big systems works is boxes and arrows. So we got to show some boxes and arrows. This was my system. I owned some social media APIs. There was a React front end, and then I owned these Java APIs. I had various endpoints to get the social feed, get reporting, had connections from Kafka and databases. But then, of course, this was microservices, and in order to get done what I needed to get done, I had to pull in information from a company's API, a contact's API. I needed information about product entitlements. Of course, all of those systems needed information from authorization and authentication. We needed the configuration information for the whole system. But what I found actually was that feature flags really weren't just for people. What I ended up doing was often the best code that I could ship was code that had no way of breaking anything whatsoever. And the best way that I could do that was to just make a new endpoint here. And obviously, if no one is hitting the endpoint, I can't possibly break anything. That's my sweet spot. That made this all work was what I would call some dynamic service discovery. Service discovery sounds like a big scary word, but really it was just a nice system for our React front ends to get the current social reporting URL. And then I could easily configure that for my user or in staging to point to my new V2 URL. So a little bit like feature flags, but really it felt more like service discovery. And this was fabulous as well. So that's cool. That's cool. That was fun. But obviously, is this just a microservice thing? Is this really something that we were going to embrace in our majestic monoliths? Isn't the dark side of all of these microservices too much to overcome? Don't distributed systems mean distributed failures? Here I'm showing that we've got some latency in the auth service. And of course, this will ripple through the context service, ripple through the things, cause trouble everywhere. You have a distributed system. It's sort of one poop in the punch bowl and kind of ruin it for everyone. Apologies, ChatGPT didn't do a good job censoring that one. But it turned out the tools that we had to control these systems really blew my mind. And that's the first thing I want to show you today. So we're going to do a little simulated example to kind of get a feel for it. We've got 2 Rails services. One has a single controller. It's called the Cascade controller. One is simulating sort of an underlying backing service here for authorization. And so everything is configured sort of out of the box. We've got 5 Puma threads in each of them. The first controller is just going to call the second controller with Faraday. The second controller here is going to put a random sleep in to sort of simulate doing some work. And so when I run this locally for a bit, I get about 2.4 requests per second in throughput, no errors. Median response time is or somewhere around 2 seconds, which makes sense because we're getting a RAND 4, and the 95th percentile is 380 milliseconds. So that all makes sense. What we're going to do now is we're going to simulate what happens when we have some bad tail latency. So a really naive and simple version of this, we're going to say that 10% of the requests start taking an extra 10 seconds. You can see I've enabled this here. Tail latency equals if this flag is on, add 10 seconds, otherwise 0. So we'll turn this flag on. Let's do 10% here. So I'm using a tool called JMeter to hit this. You can see that the samples are coming in here. We've got our throughput over here. We've got our error rate, and we've got the median and maximum times. We'll let this bake for a second and get our results. So we've let it bake for 130 samples, and you can see now the 95th percentile, our tail latencies of our overall service are not good anymore because sometimes there's these 10-second latencies. Medians are fine. So the question is, what is the right combo of the timeouts and retries to optimize across all of the different variables, our throughput, our error rate, our response time across percentiles? For this example, it's not that hard to find the right answer. We've got our timeout here for Faraday, so we can just go in and edit this. And we don't want a 30-second. We know that if it's about 5 seconds, if it's more than that, then we've hit the bad case and we should retry. So we can see now it's set to 5 here, but we do need to retry. So let's also change our retries here to be 3 retries. If we rerun our service here and let it bake, we will see that timeout is about right. Once we've gotten to 5 seconds, we know we are in that bad case, and it would be better to take that 90% chance of doing it again and not hitting that case to sort of bring it down. Because we know the specific challenge that we put the system in, it's easy to pick the right value. You can't always get it right on the first go like this because the distribution in the real world is going to be more complex, and there are going to be more and different and interesting edge cases. But the fix that we put in here does work well. We bring up our throughput, we keep a 0% error rate, and we've been able to cut the 95th percentile down by about 5 seconds while keeping about the same median time. This is really an art as much as it is a science. There are a lot of different factors, and the key realization is that when you have all of your monitors up and all of your systems running, the ability to experiment and change these timeouts and retries across the system at large led to faster recovery in bad situations, and just the ability to overall tweak and change things without having to go through a whole deploy time. So we did it. We reduced our 95th percentile times down by about 5 seconds from 12 to 7. This is hero stuff. It was very, very exciting to be able to have this kind of power in my hands. Speaking of heroes, you would not believe what dynamic configuration systems can do with log levels. So I've got another quick little app here. This one we got some Warren oranges, some info lemons, some debug kiwis. And when I hit the website, you can see right now we have got Warren debugging. But with a dynamic system like this, if we need more information, we can easily go in and we can get debug output. And then when we reload, we are going to get all debug logging from everywhere. We're going to get our debug kiwis. Perhaps if we didn't want all of this logging, we should have been a little more specific. Let's turn this back to Warren here, and let's only get the debug logging out for this controller here. And now when we reload, we're only going to get this sort of set of debug logging for the particular controller that we were interested in. Again, absolute hero stuff. Felt like so much control and power over my systems. So how do we bring this to Ruby? At the end of the day, it's not that hard. I actually, after HubSpot, I went to EasyCater, and there was a system in place that we called app, and it was the simplest thing in the world. This is toy code, but it is not all that different than what we were actually running. Basically, you have a table with a single row and a single column in it that has a big old JSON blob. Then you can put this in a class variable. start polling and reload it from the database every 30 seconds. And then all of your apps can get a key. And then in order to update this system, we'll use the Rails console to go in and make a change. And then within 30 seconds, all of the web servers would have that change. Now, there was no audit trail on this. There was no UI. We were using the Rails console to change things. We fixed all that, and it's a lot better. I would suggest using an actual dynamic configuration system. But the key point that I'm making is that it is not that hard to have a system that does this sort of thing. If you wanted dynamic logging, you could use it with a system that has no more complex than this, which just keeps a string key of the name of the class that's being logged. The value is info or debug, and then a small little filter that you could write yourself pretty easily to decide to look up that key and decide whether or not to log. So dynamic config, the technology, is not what's holding you back. It's thinking about how to make your system more dynamic, about where you could use this, and embracing that. That is the real key that I want to focus on here. So those are some things that were awesome in Java and are easy to bring to Ruby. What are some things that Ruby can do that Java just is never going to be able to do? Let's take a look at the new Rails 8 rate limits and make them even more dynamic. So if you're unfamiliar with them, this is a little bit of code in Rails 8. You can say rate limit this to 3 within 2 seconds. So all of the actions in this controller, if it goes over 3 in 2 seconds, we're going to set this alert that says you went too fast. All right, and so you can see this in action. If I reload, I can go too fast. Now, what would be obvious to make this work would be to use something like this, where we say prefab get, this is our dynamic configuration system, and we put the value in there, and then this would be a dynamic system. We can update it from the CLI or the IDE or the UI, and this should work, but it doesn't. Why not? Well, it's because in the code, this is the Rails 8 code here, which is really not very much, but you can see it is making a before action. And in so doing, it is taking the number that we passed in, this 2 number, and it's going to copy that off and then put this on this function. So this would work the first time this before action gets created, but that's sort of only going to be when the code is first evaluated. And then it's not going to ask the dynamic config system again. So it would be fairly trivial to copy paste this code to build your own small rate limit thing on top of this. We did do a dynamic lookup down in the code where it's actually looking for it. Somewhere where we reference this to, we can make this a dynamic lookup. That would be fine, but it wouldn't be cool. How could we make something like this work? How could we make a live integer version so that the number that comes out of here that is passed through the system actually live itself? And of course, it's Ruby, so we can do this. If we extend the numeric class here and make something called a live integer, which is backed by our dynamic system get here, and then we make sure that all of these methods that are on our integer are referencing this 2i. Now, every time that we are sort of going to interact with this integer, we will be doing this dynamic get. So the coerce is fun and something that I was not familiar with before. This ensures that if we have a normal number, 6, plus our live integer, that plus is actually going to be the method on the 6. And then that 6 is going to ask our integer, our live integer, for its value, and it's going to call coerce on us. These other methods here are what is happening on our live integer. So if it's live integer plus 6, then the other will come in as an int, and that will just work. This code is just a prototype. Not entirely sure this is a good idea yet, but does show what is powerful about Ruby and how it is just the greatest. So to wrap up, I think language dynamism is different than system dynamism. Ruby is the greatest dynamic language, but we could do more improvements to make our systems more dynamic, I think. And that comes when we can change the behavior of our systems on the fly. What's not dynamic? Things like restarting to change your environment variables, redeploying in order to change a log level, redeploying to change any of your configuration. What is dynamic? Well, things like rollout control with prefab flipper, where you have feature flags and targeted or partial rollouts. That's very clearly dynamic, but also things like the simple surface discovery that we showed. flow control, throw in Faraday or in Rails, dynamic timeouts and retries, dynamic rate limits, things like performance control in Sidekick or Ruby Kafka, being able to change concurrency, batch size, priorities, and pools on the fly, being able to dynamically change cache control or change cache keys can be extraordinarily useful to being able to adapt your system on the fly. And something I would call diagnostic control, dynamic logging or dynamic APM, deciding just how much logging you actually want to send to Datadog or your logging aggregator, save a whole bunch of money on some of those things by being able to control it on the fly. All right, thank you. I'm Jeff Dwyer. Thank you so much to Boston RB for making this happen. If you're interested in dynamic configuration, give a follow. Check out what we're up to at prefab at prefab.cloud, and let's make our Ruby systems more dynamic.